Okay, I'm going to try to go fast because, yes, there's no reason. So what I want to do is to get the position. Here's the position vector in Cartesian coordinates, and I want to write this, the position vector in polar coordinates, and I want to determine the velocity in polar coordinates. So if I want the velocity in Cartesian coordinates, I can just take the derivative of r with respect to t, and I get dx dt x hat plus dy dt y hat. And so I can write that as x dot x hat plus y dot y hat, where x dot is the derivative of x with respect to time. It's just a little bit simpler. Okay, but there's something here that we don't always look at, and that is when I take the derivative of this, I actually have to take the derivative of x times x hat plus x times the derivative of x hat. But in Cartesian coordinates, the unit vectors don't change, so that would be 0. So those extra terms go away. Okay, you happy? Good. Now, let's write down the, if I want to use polar coordinates, then I have the scalar value r and the angle theta. So I need unit vectors in polar coordinates. So it would look like this. I have r hat is that way, that's the direction of changing r, and theta hat that way, the direction of changing theta. So if I want to write r in terms of polar coordinates, it's not too bad. R hat. That's it, right? Because that's my distance r in the direction of r hat. That's it. It seems like it should be easy to take the derivative. So I will do that. The derivative of r with respect to t. Okay, now I'm going to do the same thing. It's going to be dr dt r hat. But now, as I move this, as my point moves, r is not in the same direction. And so r hat is not in the same direction. So r hat is not constant. So I need to also add in plus r dr hat dt. That's my derivative. But I don't want to leave it. I want to write it as a vector in terms of r hat and theta hat. I don't want to leave it like that. Okay. So if I look up here, the question is, how do I get this term? How do I get dr hat dt? How do I find that? Well, when in doubt, switch to things that you know. So if I look at this, r hat's right there, and that's the angle theta, then I can write r hat as x hat cosine theta plus y hat sine theta. I can write it in terms of the x hat and y hat coordinates. And you can check to make sure this is still a unit vector. If I take the magnitude of this, I get the square root of cosine squared plus sine squared. It is 1, so it's good. Now I can write a unit vector for theta hat in terms of polar coordinates. You can play around with it. You can see its x coordinate is in the negative direction in this case, and it depends on the sine of the angle. So this is actually negative x hat sine theta plus y hat cosine theta. So now if I want to take the derivative of r hat, I can take the derivative of this because I know x hat and y hat are constant. So dr hat dt, it's going to be the derivative of that. So I have x hat, don't care about it because it's constant. So I have the derivative of cosine is going to be negative sine theta. But that's the derivative of cosine theta with respect to theta. I'm taking the derivative with respect to time. So I also need to take the derivative of the inside of this function, which is theta. So I have a theta dot here too. And then if I do this one, I get plus cosine theta, theta dot, y hat. So let's factor out this theta dot, and I get dr dt equals dr hat dt equals theta dot negative sine theta x hat plus cosine theta y hat. And you'll see That is theta hat. So the derivative of r hat is theta dot theta hat. So now I can put that in up here, and I get dr dt, dr, the value, this dt, which I'm just going to write as r dot, r hat, plus, now I have r, and dr hat dt is this, theta dot theta hat. So that is my velocity in polar coordinates. I can write that as velocity. Now I'm going to leave it for you to work on. The v, this is equal to v, dv dt. So if I take the derivative of this, what do I get? Now, I will tell you a hint. I want you to do it. I'll tell you a hint. Okay, this is pretty easy. You have to take the derivative of both of these. You have three things here, and you get something new. You're going to have to find the derivative of theta hat. So use this definition for theta hat. Find the derivative and see if it gets something that you know. And then hopefully you can convert back. Okay, so that is the velocity in polar coordinates.